Hello everyone, I'm silentdeth, and welcome back to my Let's Play of Space Engineers, episode 15. Last episode, we built our Goal class a scout in a creative world. And as I said last episode, I'm a little bit concerned about guys following our scout back to our base and murdering us to death. So this episode we are going to work on building some defenses, specifically a S.A.M battery or some S.A.M batteries. This will be a cheap, hopefully effective defense that doesn't require any rare metals like gold and platinum and that kind of stuff. We can build it with the resources that we have already. And that will allow us to send our scout out and be fairly safe if we do get attacked. To help us with this, we have a couple of mods. One mod, the Autopilot, Radar, and Military Systems mod, adds nifty little things like radar that I'm standing on right there. Is a radar dome, a large block radar dome. It also adds this type of autopilot block here, which is, I have to say, really difficult to place. The one good thing about that autopilot block is it can talk to the radar. So that radar over there will talk to this antenna, send all the enemies it's detected to the autopilot thing, and this autopilot thing can act as a missile if we give it the command E0 ram that will attack any enemies that it detects, ramming them, which is useful, quite useful. However, there are a few downsides to using the autopilot block to do that. One, it's built, programmed, I guess you could say, to have thrusters on all 6 sides, which is a little bit more expensive. Okay, it's a lot more expensive and bulkier. It also flat out doesn't work on planets. The only way to get that autopilot block to work on planets is to turn off collision detection. And when you're trying to tell it, I want you to turn off collision detection, but then I want you to collide with something, it just sits there and looks confused. So we're going to have to use a different method. For that, we have a script. Active radar homing script. Now this is a pretty cool little script. And you saw me use this back in episode 9. This allows you to build a missile with an engine facing in one direction, and it will oversteer to correct your drift so that you can have missiles that only have one engine and thus are cheaper. And it's decently accurate. Perhaps slightly more accurate than the other autopilot one. I'm not 100% sure on that. It also works in both gravity wells and in space, which is something that we very much need. The downside is it requires a particular type of tracking. specifically what you would call image recognition tracking. You have to have whatever grid launches this missile point a remote control block at the target and hold it there long enough for the missile itself to lock on. I think I have some examples around here of that. Here we have kind of a hodgepodge missile. Over there we have a atmospheric miner that we've set to hostile. We hop in here. We switch the remote control. We switch the remote control's camera. So it's not a cockpit. Is the other one set to main cockpit? I bet it is. Yeah. There we go. This is not a cockpit. Yes, it is. There we go. Okay. Now then, we can zoom in on this, and we can fire our missile. I think. Game's lagged there a little bit. There it goes, and you can see it's now locked. Took it a little bit of time before that lock thing happened, but that's how we have to lock that. We just have to point a camera or something. We need a block called reference remote, which is a remote control block that we're controlling, and then a reference front, and I'm using the camera for that. This gives it basically a direction that you want to point to do the lock, and then the missile itself will pick the lock up from that and close in on your target. Pretty effective for flying things, but once you get down lower to the ground, that doesn't work at all. I think it's probably due to the trees. They probably have collision boxes that are bigger than their model, like most blocks. So it's probably that you just can't see through all the collision boxes when you're trying to do that. It also requires manual control, and for a S.A.M battery, we want it to be fully automated. So our goal today is going to be getting these two mods to talk to each other and setting it up so that we can automatically launch missiles against any type of intruder. First, we need to set up a few scripts here. And are you on? I think you are. That will eventually get everything set up there, I think. That's set up. So what we can do is we can use this programming block here and these LCD panels to get a list of all the detected grids with this display detected thing. Then this block here will transmit the detected to the programming block over here. And this programming block will filter this list here and output to here. Assuming I have it set up properly. Let's see. I think that works. Might not be detecting anybody at all. Let's see, when is this last updated? Yeah, that looks right. Okay. So what we're going to do, first we're going to see how to set this up so that it works properly. I'll start over here with a new little platform and get everything placed. Alright, we've got a radar, an antenna, a text panel, an LCD panel, a programming block, and power. we want to take the text panel, and to its name we're going to add open square brackets, transmit detected to programmable block, whichever programmable block we're going to be using. The name of it goes after the 2 there. We're going to be using programmable block 5, so that is what we will set. And we'll make sure all this belongs to me. There we go. That cranks that up. Now we'll come over to programmable block 5. Copy its name. Load up the radar filter script, which I'll be posting on the Steam. Then this block's name needs to be set to what we have there. And this is going to be our output panel. So we'll take its name, copy that, go back to our programmable block, and set the enemy LCD name to that. And there you can see the list has been populated. If you watch it, you can see it's about every second. It's when it updates. Though the visual thing doesn't update quite as fast, that is how fast the data is updating. We have the relation enemy, the distance 164 meters, time until last seen, the volume, the GPS coordinates of the target, and the entity ID of the target. If we go look at our programmable block, we're filtering this. So if they're an enemy, if their volume is greater than 100 cubic meters, and we've actually set the LCD name. But we have other filters we can apply: distance, seconds, time until last seen, relations, and volume we've already used. So let's use distance. We'll change this to 5 kilometers. And I think this, let's say within 30 seconds. Actually, let's change that to 10 seconds. We don't want to accidentally fire at something that's not there. And as you can see, we've dropped off the longest little enemy that was outside of 5 kilometers. Now, we need to take this GPS data and transmit it to our missile control script. It has this variable string initial command panel. And, as it says here, if we use that, if it's used, initial targeting will be based on the coordinates provided by the text panel. So we can write coordinates in the right format, copy them from here, reformat them to another text panel, then have this read of that text panel, and our missiles will know which guy to shoot at without us having to do the remote control weird thing. So what we're going to do now is create a sort of a test weapons platform to make sure all this works. A little small grid rover type thing, or maybe just a fixed installation, before we actually build our S.A.M battery itself. So really what we need to do is first read figure out how to read the data from here and transmit it to a text panel in the right format. After that, we will have to figure out how to keep track of which guy we've shot at. And then after that, we're going to have to figure out how to communicate this data between different grids, as we're going to have kind of a classic S.A.M battery setup where we have one master radar controlling multiple little S.A.M launchers. So the S.A.M launcher will need to send the targeting data to, the S.A.M radar will need to send the targeting data to the S.A.M launchers. And also keep track of who has shot what, how many missiles are remaining, things of that nature. And I'm back. It's actually been several days since I recorded the last segment. This is because patch 117 broke the radar mod. And I've had to wait for that to get fixed and try to continue where we left off. What that means for this episode is we're not going to get to as much stuff as I wanted to. We're not going to get to the S.A.M battery vehicles. We're going to instead spend the rest of this episode focusing on the missiles themselves. I have got kind of the first part of the script I need to get the two mods to communicate. If we copy this over here. So here's our list of enemies. And right here is the format that the missiles need. A square bracket, T, then a colon followed by the coordinates inside of colons. However, it reads that from the public title. I just put that on the public text so that we could actually read it ourselves. So it's reading that straight from this. Right now it's hard-coded just to get the very first entry. So it's these three numbers right here are translated to that. This is called a target LCD. And we have that set right there. The missiles that I've designed so far, we want to test out a few different types. We have some volunteers hovering over there. So here's the missile. We have a conveyor, a tier 3 hydrogen thruster, 1, 2, 3 small hydrogen tanks, a timer, a 1x1 battery, remote control, gyroscope, and optional, we have this radar here. It's really just for debugging information. The gyroscope is set up in a group called gyros. The thrusters are set up in a group called thrusters. And these can also be turned off when they're in that group so that we don't use up hydrogen fuel. If you don't know, if you have the engines on, even if they're not actually being used, they will use a tiny trickle of fuel. This applies both for electrical powered engines and hydrogen powered engines. We have our programming block, which are called missile program. Our remote is called L remote. We have a sensor called L sensor. A connector, a 1x1 merge block called dispatch. The antenna is called colon D, mid and front. Our two blocks are right next to each other. So we have the timer called mid, the battery called front. And I think that's everything. You can look at what you need right here. Just go down this list. As for other settings, we have this mid to center of mass distance. If we look at our center of mass, you'll see it's down here, and the mid center of mass is right here. As the script adjusts the angle, what it calls drift, to compensate for not having any side thrusters, it needs to know where the center of mass is. So we say this is about 0.9 meters, or about 2 blocks, just under 2 blocks, 90% of 2 blocks. Each small block is 0.5 meters, so 2 small blocks is 1 meter. 90% of 2 small blocks is 0.9 meters, and it's behind, so that's a negative 0.9 meters. And that is where we got that number. We want the natural dampeners to be false. We want a drift to be true. And a lead target to be false. That doesn't work without having this set and other thrusters. Or it doesn't work well. So we won't be using that. Over here we have our little test platform with our radar contacts, a couple of missiles. This is set to start the timer, and the timers are set to trigger now and run the missile program. So let's take a shot at those guys. Right now I have the sensors off. I guess I can turn those back on. And there's one setting we want to check. As I mentioned earlier, the trees kind of get in the way of the targeting, so we want these to go up a little ways and then dive down. That also helps with the kill shot kind of thing. As these are kinetic missiles, I tend to prefer kinetic missiles. I find that if you're using a few warheads, like 1 or 2, the warheads tend to rob the missile of its kinetic energy when it strikes. The explosion just knocks the missile back and ends up doing less damage than not having any warheads at all, which is what we're using. We have added on these little armor plates to kind of protect the vitals of the missile should they get shot a little bit. So, firing one. And you'll see that is one where we have the default 1 second launch, and it has a bad lock. If you look at the coordinates, it says, I don't know what it's locked on, but it's nothing over here, because these are all 11, and that's locked on 12 something, wherever it went. I think it probably crashed in the ground by now. So what we'll do is we'll try out a few different timings. I think we'll start with let's go with 10 seconds. No, let's go with 15. I think 15. Okay, 25. Now the problem with this is during those 25 seconds, it overrides the thrust here to be maximum, and that'll burn through our fuel pretty quickly. So what we want to do at some point is change the code, this part of the code, is change that so it's X seconds at maximum thrust, and then it's basically just enough thrust to counteract gravity. So just inertial dampeners until this timer runs out. So we'll basically have 2 timers at some point. But I'll have to do that programming off camera. Right now we're just going to get kind of a decent thing. We'll also need to figure out how much time we need based on how much fuel or how long our fuel is going to last. Whoops, wrong button. I can't push that button. Actually, it's this one. So there that one goes. You'll see it's in the booster stage. It's good that we're coming high because, as you may or may not know, those little guys will go straight towards us. If we're low on the ground, they'll stay just above the trees. Kind of like modern day helicopters. Try to sneak up on us. Now you can see that that locked on. Receiving the coordinates from that. Told it where to point. And it's diving in for the kill. Another good thing about going up and then diving down is naturally kinetic kill missiles rely on the relative speed difference, and we know that these guys aren't going to be flying straight up towards it, so there'll always be some kind of relative speed difference, and you'll see that it missed there. Even though it's a stationary target, it still missed. These are kind of wonky when they're working in gravity. You'll also see that the sensors have picked up a target and now it's using that to lock on. Missed again. It does best when it's moving in a straight line relative to the target, because we have that. Oh yeah, now that's a good kill. Because we have that lead target thing off. The lead target thing does not work well in gravity, as I've said. There's an option to build additional thrusters to counteract gravity. I have, however, found that those don't work as well as I would like, and they're really not necessary. As you can see, we did kill that guy. It did take a couple passes though, so we need to make sure we have a fuel for that. And also, the missile is going to be getting shot at while that is happening, and both targets are going to be moving. Going to be a little bit difficult. But right now, we're just focusing on the initial lock, and that seems to be working quite well. Another thing you may notice is the background color of this guy is black. The background color of this guy is white. If we copy this, wait for it. It's white now, and then it switches to black. The white indicates that this data here is out of date. Last updated 21/52/05. It's currently 13/51/10, so that was yesterday. What is happening is when you reload the save game, this portion where we have the transmit detected to programmable block does not work. It kind of forgets that it's supposed to be monitoring this. So what we have to do is we need to detect the background color of this, and if it's white, we need to have a program come change the name of this, something like that. Or probably we'll just call it something like temp. Wait 100 frames, which is a couple seconds. A couple seconds would be good. Then we come back. We change the name back. And that remembers. The little thing that monitors this checks to see if the name has been changed. It also checks to see if the name it has been changed to is the same name, not counting spaces. So you need a different name, not counting spaces. Which is what we did by naming it Programming Block 2, waiting until the program checked. It only runs every 100 frames. It only checks 100 frames, every 100 frames. So we let it check, see that it had a different name. Then we change the name back. And it would, oh look, it's a new name. It has the right format for us to be monitoring this. So I'll start doing my job. Now, as I said, the patch has kind of thrown a monkey wrench in our plans for today. What we're going to be doing, off camera, is I'm going to finish the kind of scripting for this, and we'll come back in the next episode and look at the two vehicles, the radar vehicle and the S.A.M launcher vehicle. I've kind of started on it, but I did not know the exact dimensions I was going to be needing until we finish designing the missiles here, which I think are going to probably look pretty much like this. Based on a rough estimate, these tier 3 thrusters should have enough thrust to do what we want to do with this missile. What we are going to do is we'll be using a regular expression. If you don't know what a regular expression is, it's sort of a formula search pattern. Instead of using like a word in a search program, like Google searching for, I don't know, GPS detected, instead of searching for that, we can define the search as a pattern or a formula. So what we'll be doing is we'll be saying search for a GPS detected number sign followed by some number or one or more digits, followed by a colon, followed by one or more digits, followed by a colon, followed by one or more digits, followed by a colon, followed by one or more digits. Then followed by colon, followed by ID colon, then one or more digits. And that'll be kind of our match, and we can count how many matches that are. So for instance, if you wanted to use regular expressions to count the number of sentences in a document, you would say search for a letter, followed by a period, followed by a white space character, which is a tab, a space, or a new line, followed by a capital letter. And that would be a regular expression that you could search for, and it would just tell you how many hits you had, and you would know how many sentences you had. In the same manner, we can detect how many enemies we have. We can parse out that, because when you do a search in regular expressions, you can later refer back to that search and say, I want this section of the match. So I could say I wanted the first digits match, or the second digits match with after the colon. So I would want this part, just however many of those numbers are, just give me that match, and it would do that. So that's how we're planning on doing this. I'm not sure how well it's going to work with the negative sign. That's something I have to check. I hope it works fine. We'll wait and see. I can always add in, it might be negative, into the little code. So, that is what I'll be doing between episodes. And how we're going to be memorizing what target we're going to be firing at is what we'll do is, as I said, the missiles only read the public title. So what we'll do is we'll write the entity ID, the ID down there, into the public text. And then the radar program will tell it, I want you to fire at this entity ID. And it will just look for one of these that has the entity ID that matches what the radar program told it to in its public text, which is a little bit complicated without actually seeing it, but you'll get to see that next episode, hopefully. It may take a little bit to actually do all that. I don't know. I haven't done it yet. I don't know how long it's going to take. And after that, well, we'll have to wait and see what we're going to do the episode after that. So, like if you like, subscribe if you're not, leave a comment if you have anything to say, I'm sorry this took so long. Blame the devs. Thanks for watching, and I will see you next time.